hace un montón de tiempo, 3 años hace que llevamos detrás de Avi Loeb para que pueda estar en el Congreso. Siéntense, por favor, vamos a empezar. Y así ha estado comprometido, les puedo asegurar que esto estaba así. El problema por el que físicamente no está, y ahora nos dará todos los detalles al que podrán preguntar al final de su exposición, radica en una, vamos a llamar, por no emplear la palabra prohibición, la palabra recomendación que la Universidad de Harvard le trasladó a que no viajara a España por el peligro de la variante Delta. Entonces, bueno, están... por el peligro de la variante Delta. Entonces, lamentablemente, no puede estar físicamente con nosotros, pero ya está al otro lado de esta conferencia Zoom. Yo voy a pedir a mis compañeros que ya le pongan en pantalla para presentar como es debido a Avi Loeb. Este hombre, este astrofísico, tiene una singularidad, y es que, además de astrofísico, él quería ser filósofo. Y unir la filosofía y la astrofísica ha sido algo verdaderamente excepcional, porque abre la mente. La filosofía abre la mente. Y tenemos un científico con todas las de la ley, porque, agárrense los machos, es profesor de ciencia de la Universidad de Harvard, doctor de física de la Universidad Hebrea de Jerusalén, dirigió el primer proyecto por la iniciativa de defensa estratégica. ¿Se acuerdan ustedes de la famosa Guerra de las Galaxias de Ronald Reagan? Bueno, pues él estuvo también involucrado en esto, es miembro del Instituto de Estudios Avanzados de Princeton, y yo tengo que confesar que he quedado prendado con uno de sus 8 libros, el último concretamente, que lleva por título Extraterrestre. Hoy nos va a hablar del proyecto Galileo. Avi Loeb, un fuerte aplauso, por favor. Hi, Avi. ¿Podemos ponerle en pantalla, por favor?
Thank you very much for the introduction. It's a great pleasure to join you. I must first apologize for not being able to be in person at the meeting because of the rules of Harvard University. I'm not allowed to travel as of now to Europe, but I very much hope to be able to join you next year. Hopefully the pandemic will be over by then. And I'm very sorry not to be able to be in person in the room, but I will try to do my best and communicate online, and I will be happy to answer any questions that you have after the end of my presentation. So my talk today focuses on the book that I published 7 months ago, and it received a lot of attention, translated to 25 languages, including Spanish. And I should say half of my DNA is Spanish, and that's the better half. You can see the book in the American version in the middle of this slide. And if I had to summarize it, I would say, when you're not ready to find exceptional things, you will never discover them. What you see on the right-hand side of this slide is a textbook that I published a few months ago, in addition to this popular level book, and that is called Life in the Cosmos. It was published by Harvard University Press, and it includes material that will be useful for researchers that explore life in the universe, either primitive life, microbial life, or intelligent life, technological life. And what you see on the left side is a photograph of a picture that was hung on the wall of the Berlin Brandenburg Academy of Science and Humanities in October 2020, just a year ago. This photograph was taken by the German photographer Herlinde Quilbel, who came to my office at Harvard and asked me to write on the palm of my hand a question that I regard as most important in science. And I wrote, "Are we alone?" And just a month ago, I received an email from a rabbi during the Jewish high holidays that decided to give a sermon about my book. And I found that very interesting, because apparently this subject of the search for intelligent life is of great interest to people with religious beliefs as well. And a colleague of mine said, next time we meet for dinner, my wife and I will ask you to give a sermon. And my reply to that was, I would never lead a congregation whose members agree with me. And again, a month ago, the United States Congress decided to establish an office in the government that will address the nature of unidentified aerial phenomena, so-called UAP, or in the past, unidentified flying objects, UFOs. So that's an interesting development at the government level in the United States. Now, the one thing I've learned from practicing astronomy over several decades is a sense of what I call cosmic modesty, because we know that about half of the sun-like stars host a planet the size of the Earth, roughly at the same separation. We know that from the data coming from the Kepler satellite, and this was inferred about a year ago. And therefore, there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. So when we look at a painting like the one in this slide that shows a king very proud of himself after conquering a small piece of land on Earth, that doesn't look very impressive, because this king is just like an ant which hugs a single grain of sand on the landscape of a huge beach. So what the universe tells us is that we should be modest. We are not the main player, and we are not at the center of the universe as advocated thousands of years ago. But I can understand where this notion of us being at the center of the universe comes from, because when I watched my daughters that you can see in this picture, when they were young and stayed at home, they thought that they are the smartest in the world, that they are at the center of the universe. And that notion changed when we took them to the kindergarten. They met other kids that might be smarter than they are. And so our civilization will mature by finding others. And we know that most stars formed billions of years before the sun. We can tell that from surveying the star formation history of the universe. So the sun is not a typical star. Most stars are less massive than the sun, and most of them formed long before the sun. And we know that about half of the sun-like stars have a habitable Earth-sized planet. So it's completely natural for us to imagine a civilization as advanced as we are that predated us by 1 billion years. And we are currently developing artificial intelligence systems, AI systems, that are driving cars and will make medical decisions. Within a decade, they will outsmart us. And we can imagine as the next step, sending them to space So far, we sent relatively dumb equipment. Even the Perseverance rover on Mars is just a robot that gets instructions from NASA. It's not autonomous. But in the future, we could replace astronauts with AI systems. These are systems that are intelligent, can think for themselves, and do not need guidance from us. And that is very important because the distance between stars is very large, and there is not enough time to communicate with a spacecraft that goes to another star. The nearest star is 4 light years away. It takes light 4 years to traverse the distance. So you want a system that can think for itself, that is not waiting for guidelines from the sender. And if we can imagine doing that, sending AI systems to space, perhaps equipped with 3D printers so that they can repair damaged parts or even reproduce themselves, then maybe another civilization that existed 1 billion years ago did that already. And in that case, it's possible that within 1 billion years, it pretty much populated the entire Milky Way galaxy with AI systems that replicated themselves. So are we living in such a reality? It's not a philosophical question. This is a question to which we can find the answers by looking through our telescopes. And that's what we intend to do, in fact, in the Galileo Project that I will describe in a minute, because we don't want to repeat the mistake made by philosophers 4 centuries ago when Galileo said, when I look through my telescope, it looks like the Earth is moving around the sun. But the philosophers argued, no, we are at the center of the universe, therefore the sun is moving around the Earth. And they put Galileo in house arrest. Today, they would cancel Galileo on social media, but that only maintained their ignorance. The Earth continued to move around the sun, irrespective of the mistakes made by these philosophers. And today we send space missions that use the fact that the Earth moves around the sun. So we don't want to repeat the mistake of those philosophers. We want to answer the question, are we alone, using telescopes? And that is the basis for the Galileo Project that I established about 2 months ago. Because extraordinary conservatism that you find very often in the scientific community leads to extraordinary ignorance. And what we plan to do in this project, and you can find more details through the link that I have in the middle of this slide, what we plan to do is look through telescopes. So just to give you an example, if you consider a telescope that has a size of 1 meter, it can obtain an image with 1 million pixels, a megapixel image of an object that is roughly the size of a human at a distance of 1 kilometer. And what that means is that these UAP, unidentified aerial phenomena, can be resolved. We can tell the label made in exoplanet X and differentiate between that and another label that says made in China or made in Russia. We can definitely tell the difference between human-made technologies and something else using a high-resolution image. And that's what we plan to do using a telescope system that includes optical telescopes, infrared sensors, and radio detectors. And then we plan also to look, as a second branch of the project, we plan to search for interstellar objects similar to Oumuamua, this object that was first discovered in 2017 as the first object from outside the solar system that visited near Earth. And it didn't look like a comet or an asteroid that we've seen before. So we want to collect more information, more data on objects like it. And on the 25th of June, this year, as you well know, there was a report delivered to the US Congress by the intelligence agencies that suggested that there are objects whose nature is unclear. They do not behave like human-made objects, but we don't know what they are. And when the government, which is the most conservative organization, admits that, that is the point where, to me, it sounded like this subject needs to move into the mainstream of science, where scientists would explain what the nature of such objects is. And that's what the Galileo Project aims to do, using a set of instruments over which we have full control. The data will be open to the public once we collect it, and the analysis will be transparent. So we will just do scientific measurements that would allow us to infer the nature of objects in the sky, and the sky is not classified. The research team includes by now more than 30 people, mostly distinguished astronomers that you can see here, with a number of people from Spain, actually. And we also have a scientific advisory board, a philanthropic advisory board, and a public outreach team, and a lot of research affiliates. Altogether, more than 80 people involved in this project, and we just started 2 months ago. So it's quite remarkable. There is a lot of interest. I received thousands of emails from around the world. This project started because a few multi-billionaires came to the porch of my home and offered me $2 million altogether after asking me questions about my book. They were inspired by the vision. And what we need to accomplish the task that we laid for ourselves is 10 times more funding, more like tens of millions. And I very much hope we will receive more funding in the future. The fundamental question that stands before us is the future of humanity. Because currently all our eggs are in one basket here on Earth. And we might want to spread those eggs because there are risks here on Earth. There are threats from climate change, wars, pandemics, or technological catastrophes that are self-inflicted, but there are also external threats. The dinosaurs were killed 66 million years ago by a giant rock the size of Manhattan Island that impacted the Earth. And in 1 billion years, the sun will burn up everything on Earth. All the oceans will boil off. So we need to find alternative places for us to be in, meaning going to space. So let me say a few words about my personal journey to space, to exploration of space. I was born 59 years ago. You can see me on the top left as a kid that is 7 years old. And I was born on a farm. I used to collect eggs every afternoon in Israel. And I used to drive a tractor to the hills of the village and read philosophy books. Philosophy was really my passion. But because of circumstances, I ended up pursuing physics and eventually astrophysics. And then in May 2015, as you can see at the bottom left, an entrepreneur from Silicon Valley named Yuri Milner came to my office and asked me whether I'm willing to lead a project that will visit the nearest star, Proxima Centauri. And I told him, well, you know, the nearest star is 4 light years away. So if we want to get there within our lifetime, meaning let's say within 20 years, then we need a spacecraft that travels at 1/5 of the speed of light. And that's 1,000 times faster than the chemical rockets that we have launched so far. So it's very challenging. I told him I need to think about which method of propulsion can achieve that. And then 6 months later, I proposed a possible solution, and we announced the project in April 2016. in the company of Stephen Hawking and Freeman Dyson, as you can see at the bottom middle panel. This is an artist's illustration of the solar system. You see the sun on the left and the nearest star system, Alpha Centauri, on the right. And the solar system actually extends halfway to the nearest star in the so-called Oort cloud that contains rocks left over from the construction project of the solar system. This is an artist's illustration of the nearest star called Proxima Centauri. It's actually a dwarf star that is 12% of the mass of the sun, has roughly half the surface temperature of the sun, so it's much fainter than the sun. But it so happens that there is a planet 20 times closer than the Earth is from the sun. And that's exactly the habitable region around this star. But the star is half the temperature of the sun, so it emits mostly infrared light. And because this planet is so close to the star, it's tidally locked. Just like the moon shows us the same face at all times, this planet shows the star the same side at all times as it moves around every 11 days. So for this planet, a year is 11 days. If there are any living creatures there, they celebrate a birthday every 11 days. And moreover, there is a permanent day side and a permanent night side. So my daughters said, if we ever go there, they want to live on the strip that separates these two sides. Because if you sit on the porch there, you will see the sunset forever. The sun never sets. And so I asked students in my class if they know of any creature that has infrared vision here on Earth. And one of them found a shrimp whose eyes look like ping pong balls, as you can see in the middle picture here. And this student said, it does look like an alien to me. Now, how can we get there? The idea is to push on a very lightweight sail, a thin film of material with a laser beam that is very powerful, 100 gigawatts. And if the sail is roughly the size of a person and weighs a few grams, within a few minutes you can launch it to a fifth of the speed of light. And you can equip it with electronics that includes a camera, navigation device, communication device. And this is called the Starshot Initiative. So let me show a short video that demonstrates the concept. A lot of low power lasers combine their beams to make a 100 gigawatt laser beam that shines through the Earth atmosphere and reaches a sail that is deposited above the atmosphere from a mother spacecraft. And then for a few minutes, the laser shines on the sail and pushes it to a fifth of the speed of light across a distance that is 5 times the distance to the moon. And after these first few minutes of the launch, it takes 20 years for the sail to reach the nearest star, Proxima Centauri. And once it gets there, it could potentially take a photograph, a picture of the planet near the star and tell us through that picture whether there is life on that planet. And of course, when it sends the signal back to Earth, this photograph, it will take 4 years for that signal to reach us. So altogether, 24 years, a very long time. Interstellar distances are huge, and it doesn't make any sense for humans to travel across these distances. But you can imagine another method for launching a sail close to the speed of light. using a natural source of light. If you park sails around a star that is about to explode in a supernova, then in principle, you can benefit from the flash of light that is produced once the star explodes. And it's sort of like surfers waiting for a giant wave on the beaches of Hawaii. Except here, the surfers are waiting for a wave of light that will carry them. And if they are parked at 100 times the Earth-Sun separation, they can reach the speed of light. And an analogy is dandelion seeds, as you can see on the right-hand side of this slide. Now, the fundamental question is, are we the smartest kid on our block? And I think most likely not. We are probably kind of average. That would be my guess. And that's based on reading the news every day. Because I define an intelligent civilization as a civilization that follows the guiding principles of science, meaning sharing of evidence-based knowledge. And one thing you find throughout human history is that we don't share a lot. Even when COVID-19 appeared in Wuhan, China, the information was not shared with the rest of the world. It could have saved a lot of lives. And the other thing you don't find very often in policy decisions is that they are not based on evidence. You know, that is the second guideline of science. So my guess is probably there are smarter kids on our block, and we should look for them. We should look for evidence that they left. And the best place to start the search is in our backyard, the solar system. And in fact, in 2017, the Pan-STARRS telescope on the summit of Haleakala in Maui, Hawaii, discovered the first object from outside the solar system near Earth. It was given the name Oumuamua, which means a scout in the Hawaiian language. And you can see it here circled in blue on the background of stars that are moving relative to it on the sky. Now, this object started at a very special frame of reference, the so-called local standard of rest, which is the frame that you get to when you average the motions of all the stars in the vicinity of the sun. It's sort of like the local galactic parking lot. And Oumuamua was at rest in that frame. It was not moving much. Only 1 in 500 stars is so much at rest relative to the local standard of rest as Oumuamua was. So it definitely could not have originated from any of the nearby stars. It was like a buoy on the surface of the ocean, and then the sun was like a giant ship that bumped into this buoy that was sitting at rest to start with. And as the object tumbled every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that the object has a very extreme shape. Most likely pancake-like, disc-like shape. This is a scientific paper that analyzed the variation of reflected sunlight from the object and concluded that at the 90% confidence level, it was most likely disc shape, not cigar shape. What you see are plots of the orientation of a disc-like object that would reproduce the light curve. And dark means high probability. So a disc-like object is much more probable. There is much more dark in this plot than a cigar-shaped object on the right-hand side. And more interestingly, When the Spitzer Space Telescope looked at this object, you can see the image on the top right here, it didn't detect anything. There was no cometary tail, no gas, no dust, no carbon-based molecules surrounding this object. It was definitely not a comet. We can say that for sure. Not a comet of the type that we have seen. The limits are very tight on any evaporation from it. Nevertheless, this object exhibited an excess push away from the sun, which usually for comets is a result of them evaporating. There is a rocket effect. But in this case, we didn't see any evaporation. So the question is, what was pushing this object? And the only explanation that I could think of is the reflection of sunlight, because the force that was pushing it declined inversely with distance from the sun squared in a smooth fashion, just like you expect from an object reflecting sunlight. But in order for this force to be effective, the object had to be very thin, like a sail. And nature doesn't make thin objects. So I suggested maybe it's artificial. And that is really the fundamental question. Is Oumuamua natural, a rock, or is it artificial, like a sail, very thin object? And I should say, in September 2020, after I finished my book, there was another object discovered, given the name 2020 SO. And the astronomers that discovered it with the same telescope in Hawaii, Pan-STARRS, at first thought that it's an asteroid, but then they extrapolated the trajectory back in time and realized, no, this object actually came from Earth. It's a rocket booster that we launched in 1966 as part of a lunar lander mission. So we know that it's artificial. And we also know that its walls were very thin. And in fact, this object exhibited an excess push away from the sun by reflecting sunlight without a cometary tail. And we can understand why. Now, this object was not designed to be a light sail, but it shared the qualities of Oumuamua. And so perhaps Oumuamua was just thin, not for the purpose of being a light sail, but for a different purpose. It could have been a receiver that is tumbling. And we know that this object, 2020 SO, was artificial because we produced it. The question is, who produced Oumuamua? And let me summarize the anomalies of Oumuamua. First of all, we didn't expect it to exist, because when I wrote a paper a decade earlier predicting how many rocks we should expect from other stars, based on what we know about the solar system, we didn't expect any rock to be detected with Pan-STARRS. There were too few of them predicted. Then this object, Oumuamua, originated from the local standard of rest. Only 1 in 500 stars are as much at rest in that frame as Oumuamua was. The brightness changed by a factor of 10 as it was tumbling, implying a very extreme shape, most likely disc-like. And then it deviated from an orbit shaped by the sun's gravity. And the only explanation I could think of is a push by sunlight. Now, other scientists tried to explain this object as a natural object. What were the suggestions? There were a few of them. One said, well, maybe it's a cloud of dust particles that are very loosely bound, like a dust bunny, 100 times less dense than air, so that it's lightweight, and by reflecting sunlight, it gets pushed. The problem with this explanation is that a cloud of dust particles, 100 times less dense than air, would be destroyed when it gets heated by hundreds of degrees as it gets close to the sun. It will not maintain its integrity. Another suggestion was maybe it's an iceberg of hydrogen, a chunk of frozen hydrogen so that when it evaporates, we don't see the hydrogen because it's transparent. So it's just like a comet, except made of pure hydrogen. And the problem with this suggestion is that hydrogen would evaporate very quickly and would not survive the journey through interstellar space. And then there was another suggestion. Maybe it's a nitrogen iceberg that was chipped off a planet like Pluto around another star. And the problem here is that there is just not enough nitrogen in the Milky Way galaxy to make enough chips so that we would see one of them as Oumuamua. But the important point is all of these explanations that scientists proposed that provide a natural origin for Oumuamua, they all contemplated something that we've never seen before. And they all have problems. So these are plots of how quickly a hydrogen iceberg evaporates. It takes only a few million years, which is a small fraction of the duration of a journey through the Milky Way galaxy. Usually takes hundreds of times more to travel through the Milky Way galaxy. So such a chunk of frozen hydrogen would not survive, and because of the absorption of starlight. And the same is true for nitrogen icebergs that would be evaporated by cosmic rays. And there is just not enough nitrogen to account for a population of objects like Oumuamua. And this is an example of the authors of one of these models, the hydrogen model, admitting a month ago in a paper that they published, they said the hydrogen and nitrogen models have serious difficulties. So not only they contemplate something that we've never seen before, we don't know if nature makes those icebergs, but moreover, there are serious challenges to these models. And my point is, when you walk in the beach, most of the time you see natural rocks, just like the asteroids or the comets that we often see in the solar system. But every now and then, you see a plastic bottle that indicates that a civilization is out there, and that may be Oumuamua. Now, if you imagine a caveman finding a cell phone, at first the caveman would say, oh, this cell phone is a rock of a type that I've never seen before. This would be just like astronomers saying, Oumuamua is a rock of a type that we've never seen before. It's a hydrogen iceberg, a nitrogen iceberg, something we've never seen before. But the point is, this is just the beginning of a learning experience, because the caveman could push a button and realize that this cell phone would record his voice. And he can press another button and realize that the cell phone can record his image. And at that point, it will become clear that the cell phone is not a rock. It's something else. And so for us to understand that, we need more data on objects like Oumuamua. And that is the purpose of the Galileo Project.